we need to recall everything. There's a few steps that we should think about and different structures. First is you consider whether your denominator can be factorized or not. Like something like this, fx squared minus a squared or a squared minus fx squared. This can be factorized. You can do your a plus b, a minus b. But if it's these two formats, just specifically these two, you will use MF27 formula, which is this square bracketed part on the right side. If you have a squared minus x squared, go for this particular formula. Okay, so let's apply it to our problem. In the denominator, can we rearrange? Remember this set of formula you want to write as a fx squared. Okay, the x term there, write as a fx squared. Remember again, I remind one more time, you must create the f prime. You must create the root 2. And we balance outside the equation 1 over root 2. So we integrate, I leave the 1 over root 2 outside. 1 over 2a ln. All lns will come with mod, even if the formula list puts a round bracket, they have a certain condition on the right side. But don't worry, we will always put modulus unless you know it's positive. Let's see. It could also be you have factorizable. So we always check can factorize or not. But if it's not the above structure, not a square, x square kind, then you do partial fractions. Okay, so nothing of the above format go for partial fractions. So in this particular question, this can be factorized. So always check your denominator can factorize or not. This can be factorized. I should do x minus 1, x minus 2. We factorize it. Anything that can factorize, you factorize. And your job is to split into partial fractions. You will need to do some side working to work through the partial fractions. I just state for you the answer here. We will get a -1 and a 1 here. You need some side working to work through. I just feed you the answer here. So when you integrate, the coefficient at the top, we just write outside, and you get ln. Because it's of the form f prime of fx. So second term similar, you get a ln. Plus c. If then it's the other way around, not factorizable. If your denominator cannot be factorized, your top is a constant, then you want to complete the square. You are completing the square so that you aim for tangent inverse formula. Completing the square gives you something quadratic. In this structure, you can do tangent inverse. So I've worked out completed the square equation. We can further write as a root 2 square. We go for tangent inverse formula. I just write below. We get 1 over root 2 tangent inverse fx over a plus c. And next row, not factorizable, but the difference is my numerator is not a constant. It's an equation that has a variable x on that. There are certain things you need to do. This is not specific to just this row. When you always have a fraction, you should consider long division. And you do long division if the power or the degree at the top is the same or larger than the denominator. Same or larger, you need to do your long division. And number 2, after we have done long division, like our equation here, let's say you have long division worked out, what you need to further do will be, you need to go and force out, I just use this word, force out your integration of f prime over fx. Okay, what I mean by that is as follows. I just write on the next line. When I integrate the 1, we get x. Let's split it up. For that fractional term, denominator stays. Force out the derivative to appear immediately. Force 2x minus 2 to come out. Okay, differentiate the denominator, force it out above. Balance. When I balance, you balance the x first. I want to make it back to x. So there will be a half. Half times 2x gives you back x. Half times constant minus 2 is negative 1. To make it minus 3, we minus another 2. Okay, force the derivative, balance the x, balance the constant, and we break it up into a few terms. Okay, so let me explain. For this term here, you will get your ln, since it's f prime over fx. But can you put a round bracket first? I will talk about that later. I will write in the reason for you. Okay, so let's write this first. Ln's usually modulus, but this particular case, let's put a round bracket. I finish up the right side first, and I explain that. What is this? This came from your previous question. It's the same one. I use the same numbers. So when it's this form, you should have completed the square, and then we get tangent inverse. Okay, so let me just fill in the answer. Okay, so why is this round bracket? Remember, I told you, ln, you put mod unless it is positive. Is this positive? It is. Why? Because you should have, as part of this step, completed the square. When you completed the square, it's a plus 2. Something square plus 2 is always more than 0 for all x values. If you have a term within the ln that is positive, you should change to a round bracket to simplify it. In fact, this will surely be true as long as it's not factorizable. Because if it's not factorizable, there will be no roots. If there's no roots, means the equation positive. Okay, or it could be always negative, but in our context, should always be positive. Okay, not factorizable already mean you have no roots. Okay, no roots will be positive. Okay, but to show better that you have completed the square, then just tell them always positive. Okay, for those with a square root in the denominator, like this question here, please don't think about partial fractions. So you don't check factorizable, not necessary. Or rather not, you should not even do that because you cannot do partial fractions. If there's a square root, there's no way you can split. So numerator is a constant, just like above, we will be completing the square. Because with a square root, we aim for sine inverse. Sine inverse formula comes with the square root. Okay, so I have completed the square for you here. Again, just to emphasize one more time, sine inverse, this is the fx. F prime is 1, so we are done here. I can just write in the formula. Now fx over a plus C. And if my numerator is not a constant, the previous one is a constant, this is not, what do we aim for? When the top is not a constant, with a root, you are aiming for f prime over root fx. Just now, it was f prime over f. Now, with a root, it's f prime over root fx. And you aim for that right at the very first line. So denominator, I don't make any change. I want to differentiate the term within that square root, which means I will get minus 2x. Force out the f prime to immediately appear at the first line. Balance the equation, the coefficient of x must be 1. So I want to balance with negative half. Negative half times minus 2, your current constant is the plus 1. I want to make it plus 2, so I add another 1. We split into two terms. At the same time, for the term on the left, can I rearrange to be without fraction? So I want to write the denominator to go up. Okay, the term on the left, can I move the denominator to go up? Okay, why are we doing it this way? F prime fx power n. So when you integrate, this is the one where you go for power plus 1 divided by power. And second formula is again the same as the previous question. I use the same numbers. So the second one on the right, we will just get that sign inverse term.